All right, welcome everybody. I'm extremely happy that once again we're joined by Dr. Michael Clarage, who I think many people here, that's him, the guy who just raised his hands. I think everybody has probably seen at least one or two of his classes for the RTF. I know many people had been requesting for a long time before I even reached out to Dr. Clarage for us to do this and to host Michael because of his incredible work on such inspiring projects as the Sapphire Project. I know a lot of people here have been following that for a long time, but Michael's also a very universal thinker. He doesn't make the problem that many, or he doesn't suffer from the problem that so many analysts and scientists tend to suffer from. And I would even say artists, as far as dichotomizing different fields of the human experience, the arts, the aesthetics, the sciences, and just how that applies to making life better for human beings more generally. So what we'll do is when people, if you haven't gotten a chance to experience already Michael's approach to teaching, to making discoveries, and to making those discoveries as transparent and intelligible as possible for a broad audience, check out the links in the description box as well for the previous lectures he's given. What's really wonderful as well that I always enjoy is the fact that, and I was just saying this before you got on, Michael, with the audience here, is that you're also a high school teacher on top of these various hats you wear, and it really has demonstrated, or it produced a quality of passion to take complex ideas at the frontiers of human knowledge and to translate them into content that is understandable by anybody, even kids, capable of utilizing their God-given powers of reason. And it's rare, again, to find that. So the 4 article series that caught my attention a couple of months ago that you put out on toroidal fractals is challenging. I can't say I understood a lot of it, but I get the general essence of what you were pursuing, what hypotheses you were putting out, and definitely we see all sorts of incredible evidence that the universe is not random. It's not governed by a causation or a causality or randomly rolling of dice. There is evidence all over the place, if we have eyes to see, of order, of beauty, of symmetry that has certain characteristics, and you've definitely zeroed in on a number of fundamental aspects of that that manifest into both galaxies as well as the smallest domains of the microcosm. So after your opening remarks, we're going to do like usual and open up for some dialogue with the audience. And to keep things a bit orderly, I ask people generally to put up a digital hand or to put your name in the chat box, and I'll call upon you in queue that way to share a thought or pose a question. Otherwise, Michael, the stage is all yours. Thank you so much.
Great. Thank you so much for the introduction. I'll continue to be impressed by the sheer amount of activity you and Cynthia put out. I thought I could walk through the articles to kind of set the stage with the geometry and the physics and try to convey how even at the simplest level, this is new physics, only meaning that people haven't really studied it. And then maybe we could switch to the galaxy lecture on structures, similar structures in the galaxy. So that's kind of my plan. If for any reason that starts to go off the rails, and everybody's free to say, sorry, can you change your plan, please? It's not working. Okay, so let's start with, oops, I don't know why I have to go through multiple clicks. Very good. Now you're seeing it, right?
Yep. Well, that's, yes, there.
All right, very good. Yeah, so this, all of this started, this particular series started because Bob Grenier and myself, Bob's an independent researcher who's done tremendous work in the field of low energy nuclear reactions. He and I both have kind of, started working on this. We recognize each other was working on it. We've been trading messages now and then. We read each other's Substack works always. So what is it? What is this torus thing, especially what's a fractal torus? A torus we all kind of know. It's the donut. And there's lots of examples of donuts in nature. Smoke rings, when someone blows a smoke ring, That is a torus, and it has a it is oddly persistent. It has a unity to it that is not easy to explain with just simple physics. But it's difficult to break apart. It has a structure. It wants to stay together, so to speak. However, what we're starting to see is that that donut could be made up of donuts. And so here's one of Bob's renderings of this. The big orange thing is the donut, the torus shape, which then, as you can see, is made up of a bunch of donuts that are oriented the other way. They're oriented perpendicular to the larger whole that they're a part of. And then each one of those can be composed of donuts, which are, again, oriented perpendicular to the donut that they are a part of. And so you get this nested structure. And the question is, well, actually, it's not a question whether or not they exist, I don't think anymore. There's been plenty of, I think, Japanese, Russian, for sure, and maybe Indian researchers into low energy nuclear reactions have seen marks that look just like this on their materials. So it's so unlikely that a structure like this would be would occur through some kind of a fake Rorschach test where everybody imagines they're seeing it. It's not really possible. So they're out there, and they seem to be connected with low energy nuclear reactions. What do I want to say on this? Yeah, so this idea of breaking things up into smaller versions of themselves is something that got a name back in the 1970s. Mandelbrot coined the term fractal, and it's a great name, and it's stuck, and it's now literally is part of just our consciousness, our cultural consciousness. Everyone knows what a fractal is now, which I think is so cool, right? That's just like 1.5 generations, 2 generations. And there's certain rules for how you break them up. If you want the thing to have the thing in itself, let me just try to zoom in maybe to one of these as a good example. These are, oh boy, these are all kind of, a lot of us have seen various versions of this. But if you have, say, a circle, no, that doesn't have the 3 parts in it. The Koch curve is good. So this starts off as a triangle, and then you put another triangle on top of each leg of the triangle, and then you put another triangle on top of each leg of that triangle, et cetera, et cetera, et cetera. This, to me, putting together this series, something I didn't include in the essays, is now I know that this is one of the meanings. This is one of the meanings in Genesis when God creates all the herbs that have their own seed in themselves, and all the creatures that have their own seed in themselves. Now, I'm sure there's 30 other awesome meanings to that phrase, but I think it also has a quite tangible geometric meaning, that you can make a structure that has the structure inside of the structure, and all of life has some aspect of that. That is in the geometry of all organic life on Earth. So if I want to take this fractal idea and apply it to the donuts inside the donuts, what do we get? So I'm not going to go through the math, and it's just going to say that what you get, if you look at the donuts inside the donuts inside the donuts, you get an object that is not 3-dimensional, and neither is it 2-dimensional. It's between 2 and 3 dimensions. And such statements are very common in, again, living situations. So your lungs, for example, they're not the alveoli, all the tubing in your lungs is not actually a 3-dimensional structure. If it were, then you couldn't breathe, because then you would just have a big sac. You would just have a balloon, right? A balloon is a 3-dimensional structure, but life doesn't work that way. Life has to break up the bigger tubes into smaller tubes, which look like the bigger tubes that have smaller tubes inside of them, et cetera, et cetera, et cetera, et cetera, et cetera, all the way down to where you get down to the individual cells, blood cells, right, can meet the air. So So I'll just say that to get an object that's not three-dimensional nor two-dimensional is not a surprise. It's quite common with this sort of thought. What's cool for the donut within the donut within the donut is also, like your lung, the area of the donut increases every time you put a new substructure in. So that's the way your lungs work. The volume is less than the volume of the air in your lungs is less than if your lungs were just a sac, okay? However, the area inside of your lungs, the surface area inside your lungs, continues to grow every time those little tubes branch. So the area is increasing without bound, so to speak, whereas the volume doesn't go up. And this is part of the magic of fractals, and it's part of the whole reason why nature does fractals, is because you need something. You need a structure that will do what I just said. Before I move on to the next page, any questions on the ideas of fractals or the torus that we're looking at here?
If people have questions at any time, keep in mind you are on mute by default, so you'd have to unmute yourself to launch into a question.
I have a quick question.
Yeah.
What role does movement play in I guess, the propagation of these fractals?
In the particular case of the little Leonard toroids, or just like any fractal in the world?
No, I revised the question in as it relates to toruses.
Yeah. Okay. So the toruses are always moving. Great question. Right. That is one. It seems that in nature you cannot have a static torus. Really, it is kind of by definition a dynamic entity which has its own movement, its own inherent movement, and there is no relativistic frame you can go to that will make that movement go away. Right? It is an absolute movement which everyone in the universe would have to agree is present in that object. Okay, I'm going to move on to part 2 then.
Wait.
I got
a question for you.
Yeah.
It's Peter. Is that the orange torus like one of those expandable accordion tubes?
I like that. Yes, it is. It's like one of those expandable tubes. Yeah. So if you could imagine an expandable accordion tube that was in a circle, it didn't have open ends, and which was also made up of expanding tubes, that would be closer to what this is.
That's amazing. I'm in.
Right. Yeah, it is pretty amazing. It is pretty amazing. Actually, before I leave this particular one, let me go to, okay, I'll just play it first and then I'll talk. So these are toruses that are being generated very cleverly by shooting 2 different colored liquids at each other. The way they're released, it's not so obvious that they're each toruses and until they meet, but they are. So those things that are shooting out of the containers, that's that ring, the self-contained ring that has rotation. It has its own inherent structure. And then you can see that without any input from the outside, the colliding toruses break up into other toruses that are now rotating perpendicular to the original ones. That's like my favorite right there. And I'm not claiming there's any new physics in this. I mean, in terms of like, hey, there's a new force or anything like that. But there is so little material on how to analyze these systems that I've been able to find, Bob's been able to find, right? It literally, it is literally a new field. And I'm very excited for future students who will learn how to talk about these things in ways that we don't yet know how to. So part of the reason I want to show this is, in addition to being incredibly beautiful, is that it kind of gives some impetus or some justification or like some, it's not crazy to think that a torus could break up into other toruses, which are smaller and which actually are perpendicular to the one they came from. And I'm not claiming that those blue and red toruses are the same thing as the physics of a galaxy or the physics of low energy nuclear reactions. I'm just trying to paint the picture that the torus is a dynamic, real thing that exists in nature, and it has properties that we are not very familiar with. And so that's part of what I'm doing, is diving into what are those properties and how can we start to understand them. As a physicist, one looks often at the energy of things and the forces involved and how can things stay together. So it's known that if you shoot an electron, that little green guy there, if you shoot an electron into a magnetic field are the red crosses, that it will just naturally spin, it'll rotate. There's really not much understanding about why that's the case. It was simply codified into a law called Lorenz's law, which states just that. We needed a law that would explain why electrons spiral in a magnetic field, and so we created the law, and there it is, right there. That's the law. I'm half joking. We observe things in nature and we codify them. If there's any academically trained physicists on the call, someone might say, yes, but what about the relativistic explanation? Didn't Einstein explain Lorenz's law? And I'm like, no, not really, but we can talk about that later if you want. So I'm looking now at this torus, that orange torus thing. I'm now going to look at it as, hey, could this be a self-contained, self-organizing, I hate that word, but self-organizing structure of electrons? Because Ken Shoulders back in the 80s, who kind of is the modern, one of the discoverers of this. I mean, other people discovered different aspects of it, but a lot of people know that Ken Shoulders is kind of like he's like the guy. He basically discovered this stuff and explored it. And he came to the conclusion that electrons can make little toruses, little meaning like a micron, 10 microns, 100 microns, so fractions of a millimeter. Electrons can come together and make a torus that's fractions of a millimeter big. And they can be self-contained. They can hold themselves together. So that's where I'm going now with my little talk here, is there any way that one could conceive of that? Because if you think about, you're trying to smush a bunch of electrons together. Electrons are all have the same charge, so they're going to want to fly apart. They will repel each other. So there seems to be a problem here. How can I get a bunch of them to stay together when all they want to do is fly apart? And the way one starts to answer that question is with this right here, this picture right here, that electrons will spiral in a magnetic field. Okay, so how can we get a magnetic field into our little torus? Well, there's the other aspect of electromagnetism where a moving charge creates a magnetic field. Again, a mystery. It's a mystery, but it happens. We know it happens. So I said, how can I keep electrons together when all they want to do is blow apart? But then the second half of that sentence is, oh, if I get electrons together and I move them, they will create a magnetic field, and that magnetic field that they create will make them spiral. So it's almost a little bit of a chicken and egg, or there seems to be almost something a little faulty in the logic, but this is how electromagnetism works out. So I'll just say it again. I want to have electrons that'll stay together in a small structure. If I can get them to move, the electrons to move, they will create their own magnetic field, and that magnetic field will make them spiral. So just the movement themselves will make themselves spiral and stay together. That is at least the direction I'm heading down with this. And so you can set up your the relevant forces involved, and you can write it down, and you can simply ask, will this be stable? Is it possible? Is it, given that we know what we know about the forces and electrons and the mass of the electron, do the equations say that it's at least possible? And the simple answer is yes. Very, very interesting that, yeah, you can actually show with classical physics that it's at least possible. And so what are some of the highlights of that analysis that I came to? One of the things is that in order to make it stable, the velocity needs to be quite high. It needs to always be in the relativistic range. So I came to an average of like 2 × 10⁸, which is 2/3 the speed of light. So that's interesting. If you want it to hang together, they got to be really moving, the electrons. But that's okay. That's not a showstopper. Also, it can't be too big. Just the way that the forces work out and the sizes. Some things scale infinitely. It doesn't matter how big they are. Other things, they fall apart if they get too big. The way the physical laws all interact with each other. And when I was going through this, what I found is that they had to stay small in order for it to work. And the range I got with this analysis was exactly the range that Ken Shoulders said they should be in, from his observations, not should be. From his observations, this was the size that he saw in his lab for whatever these objects are. I also found that the kinetic energy inside the whole thing stays remarkably constant over a very wide range of parameters. I didn't know whether to, actually, no, I didn't expect that. I thought that it would be very much dependent on the size, and that would explain why it has to break up. But this analysis says you can have a tiny one or a medium-sized one, and it has about the same energy, which is pretty cool. And then how much energy is that? So it's a small amount of mass, but it's moving very quickly, right? And so even a small amount of mass moving very quickly, like 2/3 the speed of light, will represent a substantial amount of energy. And there's also, there's energy bound up in the spiraling. It's totally analogous to think of it like a spring that, if you have two objects circling around each other and they're connected by a spring, there's energy in that spring. And you can know that because if you cut the spring, then it all goes flying apart, into pieces. So I'm just saying I added up all the different energies that are present in that system. And I got several joules of energy, which is just a measurement. It's a unit of energy. But what was exciting about it is that, again, what I got just from this little theoretical analysis in terms of the total energy is exactly in the range that what Ken Shoulders also in his lab said he was observing as the range of the energies of these particles. So again, just to summarize, I took our idea of what if we had a ring of particles, of electrons. Is that even possible from a classical physics point of view? Is it even possible to make such a thing that will hold together? And if so, how big will it be and what kind of energy will it have? And my very rough, though I think pretty elegant analysis is excitingly very much what Ken Shoulders says he observed in his lab for how these structures hold together, what their size is, and how much energy they have. Good pausing point. Any questions?
In this approach you're taking, do you need to, is there no need in this approach to account for this type of thing utilizing this strong nuclear force assumption? That's a big part of the standard model, or is this like complementary, or is this a substitute for that?
This is purely like Maxwell equation stuff. Yeah, so there's no nucleus here. There's no nuclear force. It's just looking at electrostatics and electrodynamics and Maxwell's laws, things like that.
Cool.
Did you briefly show some pictures? You went by them, but would it be helpful to show any examples like that?
From Ken Shoulders?
Nah, just anywhere on this Substack page. I thought I glimpsed for a second some examples from nature, and I was intrigued. That's all.
Oh, yeah. So I have, let's see, good question. I'm trying to remember right now. I have, we can go into the Galaxy one soon, and no, not on those.
Well, don't let it interrupt your flow, my friend.
All right, that's fine. I mean, this may be what you're thinking, but this caught my attention. One of Bob Greenyer's lectures that he gave, I think in Romania, about toroids, toroidal moments, etc. This is very much so. This is a rock carving on some temple, I believe in India or Cambodia, and in the lecture, Bob puts this right next to one of the micrographs of what we observe in some Lehner reactions. You'll see a thing that looks just like this. That's it looks like something went splat onto your metal. And then the splat is where all the nuclear transformations take place. And the splat looks like this, which was why he chose this as the opening slide of his lecture. And you can kind of see the donut made up of donuts. You can kind of see that. Now that you know what to look for, you're like, hey, is that a donut made up of donuts? And then when I was putting together this from something else, I stumbled across that, that's the nest that pufferfish make. The guys make this nest. Who knows why they make it? A Darwinian would say they make it to attract a mate, but maybe they just like making nests. I don't know. But I just thought it was fascinating that it's like even pufferfish have this. I don't think that's directly answering your question, though. Okay, so let's move on. So we looked at the structure itself. We looked at some of the physics of it. And then like the question of where does this show up in nature will it naturally occur? When I went back, let me try to find, when I went back to look at everything I had just said more carefully, here it is, yeah. Is this it? You'll notice that there's these regimes where things go flying up. And I'm not going to get into what quantities are flying. In this case, it's the speed. Zooms goes, swooping up. Whenever you start seeing stuff like that in your analysis, you know that you are, this is a good one too, you know that there's some boundaries you need to worry about. And this was the main one right here. So I know, let me just I'll try to paint this picture here. What we're looking at is the magnetic field. And the center of the donut is right here, over at the left. And then we're measuring the strength of the magnetic field as you move away from the center out towards the edge of the donut itself, the ring of electrons. If you're right in the center of the donut and you're heading right towards the ring, the magnetic field shoots off to infinity. and so you kind of know that there's going to be a problem there with your analysis because it just goes, off to infinity. And that, I'm not surprised by that in hindsight. I knew that something strange had to happen right when you get to the donut, because how is the donut going to break up into smaller donuts, right? We can start with just a donut. Where is a donut? We can start with a donut, which is part of the analysis I did with the electromagnetics and the energy. But what I'm proposing or what I'm looking for is why does it break up into smaller donuts? That's really the question I want to know about. And the magnetic field goes off to infinity as you approach the donut. And that magnetic field is what's keeping everything going in a circle. So I'm not trying to say I've proved anything. I'm just trying to say that, yeah, you know, there's going to be some strange stuff that happens when you get to that ring. Something strange is going to happen. It's not just going to behave itself. And I don't have too much more to say. I didn't come anywhere close to deriving why the donut should break up into smaller donuts. I have a suspicion that there is no way to derive it. There's plenty of things in physics where you can't go step by step to get the answer. There is no pathway with mathematical physics to get to the answer. But we know the answer is true because we see it in nature. And if you start with the answer, you can see that the answer is consistent with your physics. So that's one of Gödel's ideas, right? That there are true statements in your system that you can't derive. And physics is very much like that. There are true statements in physics which are consistent with the laws of physics and that we know happen in nature. And there is no way, there's no step-by-step way using the framework of your physics. There's no step-by-step way to get to that answer. This right here is an artist's rendering of our Earth, and it starts to convey some of the complexity. Now, the Earth and most planets, most suns, have a magnetic body, or I should say an electromagnetic body, that is a torus. The electromagnetic body of the Earth is a torus, and it is much larger than the rocky body of the Earth. And that seems to be a general principle in cosmology. Like Jupiter, we can see the gaseous body of Jupiter. And then you might ask yourself, well, how big is Jupiter's magnetic body? And it's huge. It's, I don't know, 100 times the size of the gas body is the magnetic body of Jupiter. And I know all of us, you know, being cellular creatures, we're very much biased towards thinking that, well, it's the rock that's the real body of the Earth, right? All that magnetic stuff, I don't know, I don't know. That might not be the body, isn't that kind of metaphoric? You start to speak in metaphors. And the more I study this, I'm like, no, actually, the Earth has a magnetic body that is just as much a body as the rocky body is. And the same is true of stars. All of us right now on Earth are inside the magnetic body of the sun. We look up in the sky, we see the glowing orb, but that glowing orb is not the body of the sun. It's just not. It might be the nucleus of the sun. It might be the heart of the sun. It might be the eye of the sun. But it is not the body of the sun. The body of the sun is this enormous thing that stretches out, I now think it stretches out a light year or two. So we're all inside the electromagnetic body of the sun. And so these curlicues on the picture are artists' idea of how electrons travel. And it's a very complicated trajectories for electrons. They travel around the torus, but they also spiral perpendicular to the torus. And this is just one, the artists here just kind of focused on one of the current systems, electromagnetic current systems in the Earth's magnetic body. There's easily half a dozen other current systems of electrical current. And so it would be basically impossible to render. There's too much structure in the magnetic body of planets. There's too much structure to render for our eyes to see it. So I'm kind of leaving the fractal torus world, kind of going into the natural world here. Where does this show up? And I'm starting to think that it shows up basically everywhere. If the same structure is in stars, that's on planets, you can ask, well, what about people? And if anybody's looked at the material, what's their name? HeartMath. I don't know if they're still active, but HeartMath was a company that did all kinds of research into the electromagnetic field of the heart and the blood circulation. And humans also are toruses. The overall structure of our magnetic field of a human is a torus, that has the heart as the center. And then our torus goes out, well, depending upon the person, a foot or 2 or 3 or 4 or 20 or 50, or if you're St. Francis, your torus probably goes out several hundred miles. Okay. I think I'm going to switch to the galaxy paper, unless anybody else wants to bring up something.
I wanted to say something about the electron toroids you were discussing previously.
Mm-hmm.
When you made when you created these toroids, and they dissipated the energy. Like, I suppose you tried making small ones and big ones, and seeing how the energy kind of dissipated amongst the different sizes.
Yeah, I didn't quite get that far. And just to be clear, I was creating these mathematically. I wasn't creating them in the lab, though I'm sure that's in my near future. And all I was doing when I was looking at the electron toruses was I was just taking one, and I was just saying or asking, is it possible for a torus of electrons to hang together on its own, or will it just blow itself apart just from the laws of physics?
I think it's possible.
I think so too.
There's no experiments that have been done though with this.
Yes and no. So people have circled around it. Ken Shoulders, again, is probably the best to look at. He did a lot of experiments with them. They have very strange properties. They can last indefinitely, according to Ken and according to other people. The Russians have observed these things coming out of their sample, their Lehner samples. They observed these things coming out of their Lehner samples months after the experiments were done. So they seem to be very stable, but in ways that seem almost, I don't want to say miraculous, but just kind of in ways that seem impossible.
Interesting.
Yeah.
You want a couple more questions, or do you want to go on? Because there's a few people in the waiting room that have thoughts or questions to throw at you.
Oh, sure. No, let's go with questions. I got no particular. Yeah.
All right, cool. Bruce.
Thank you. I got familiar with the work of Nassim Haramein over the last 20 years. And he did some great explanations and presentations about this kind of stuff. I'm dusting off the memory banks here.
Wow.
But it's about this part of this is coming from the elemental nature of reality, and I guess what we know as sacred geometry. To make this point, I remember in a presentation he showed that geometric pattern or form that's on the north pole of the planet Saturn, and maybe it's a 6-figure, I forget the exact name of that shape. Right. And if I recall the presentation correctly, that's a shape that is formed by the movement of a torus, where it's always swirling out and then back in. So it's this, a torus is this perpetual kind of motion of motion. And I wish I had a specific question along those lines. What do you make of what I've just shared?
Exactly. Well, I think in particular with the case of Saturn, it's such a great example. It's related to what I was saying about the lungs. Solar energy has to get down to planets. In the hierarchical universe that we live in, higher energies have to make their way down into lower realms, but those lower levels are always more dense. The solar wind is thing of incomparable rarefication that we can't even imagine. So how do you get from that down to this cold, wet planet that we live on, right? And usually our thinking is so simple. Like we just think, oh, it's just sunlight, right? That's how it's just sunlight. But the reality of what's going on is so much more intricate and beautiful. And so on Saturn, for example, what we are seeing, in my opinion, is that that large ring of the top of the donut comes down into the pole of Saturn. You're talking billions, probably maybe even hundreds of billions of amps of current coming in. How is that going to get down to Saturn without just blowing Saturn apart, right? So it has to break up into smaller vortices, and then those vortices have to break up into smaller vortices, and et cetera, et cetera, et cetera. And then you get this kind of filamentary or dendritic energy flow. So instead of one giant fire hose, again, that would blow apart the planet, it gets broken up and slowed down into a million little tendrils. It gets broken up, and then those million little tendrils can then make their way into the planet and do what they need to do on the planet.
Thank you.
Yeah.
Yeah, it's a fun idea, like approaching it because we see geometries all over nature, and you look at an apple as well, and there's definitely a geometry that's shaping the growth of the apple from a little baby seed into the apple off the tree, and everywhere you see them in that hexagonal shape in Saturn. But to use what you're describing here to help the mind imagine what is actually causing that growth for the physical matter to like grow and be sculpted into something that appears to be a fixed static object. The apple appears to be this static thing. The hexagon on Saturn appears to be static, or the snowflakes appear to be a thing. But there's this whole vibrant, invisible but much more real geometry shaping it, tied to these processes. It's very exciting.
It is. And that whole question of static, I think I try to remember that our sense of the flow of time is, what would one say, idiosyncratic? Like we think time flows at a certain rate. And so we say things like, oh, that's a static structure. The apple's a static structure, right? Whereas if your sense of time was, say, just 1,000 times faster than or slower than what we experience, the apple would be this thing that just flies through and it's gone in a minute, right? This beautiful structure that has a fivefold, you cut into the apple and you see the fivefold symmetry of the seeds. So if you sped it up, this thing goes shooting out that has this beautiful fivefold symmetry, and then it decays very quickly and goes back into the earth. And then no one would say it's a static structure, but for us it is. For us, it's a static structure.
Mm-hmm. Sherry, did you have a question?
No, I'm just fascinated. I'm hearing Dr. Clarage. I'm hearing you on the verge of quantum physics here, and I'm loving that. And I have studied with HeartMath.
Oh, great.
And I think you would very much enjoy reading something from Dr. James Oshman, who is a scientist who researches energy and the effects of quantum healing. And people are asking questions about our human frequency. And, I don't know if you've done much research in the Schumann field.
A bit.
Yeah. And how electromagnetic fields impact our bodies. And anyways, this is sort of what I am a quantum healer. I do quantum healing work. And so I'm fascinated by this physics, but I live in the quantum physics world. So I don't really have a question. I'm just fascinated.
Oh, it's great. It's great. In terms of the physicist side of the Schumann resonances and organic life on Earth, it's an example, I think, of what I was just talking about. Like, how do we scale down solar energies so that you can have birds and bees and horses and fishes, et cetera, et cetera. and that's one of the things you need, apparently, is you need the entire surface of organic life on Earth to be resonating at 7.5 hertz and 14 hertz and 28 hertz. And then somehow we all of us synchronize with that. But then we have our own personal, thoughts, etc., that fluctuate on that frequency range. But I see it as another example of this, like a scaling down. How do you get solar energies down to us?
On that note, Peter Nikitas had a quick question. Peter, do you want me to ask it, or do you want to ask it?
Thanks, man. I'll ask it. I asked a bunch of questions. What is the frequency of a human magnetic toroidal body? And it follows what frequencies amplify this frequency and what frequencies cancel. And is there any kind of music that really supports our human toroidal frequency better than others? And I set up a little equate or a little mathematical expression as an example. Is classical better than jazz? Better than rock? No.
Yes, these are great questions. I hesitate to wade into that. I mean, I think a lot of us have the perception that some forms of music are inherently destructive, and for some reason, large portions of people are attracted to it, and it's kind of a mystery. I don't know what's going on there. I am trying not to judge it, but it seems like, but maybe our previous, I forget your name already, the quantum healer Schumann resonance person, maybe you should answer that question of, are there natural frequencies to the human electromagnetic torus?
Yes, of course. And I did answer Peter. Matt and Cynthia talk about this a lot, actually, about the music and how some music that has multi-dimensionality, no sense of a pattern that's repetitive, and then it takes you into a different realm. Whereas when we're in a world where we're following that 8-beat count, it's a pattern, it's determined, it reduces our creativity. And the megahertz that music was before this rock beat music happened was, it used to be 432 megahertz, but they changed it to 430, and that's disharmonious to our system.
440. They raised it.
Yeah, they raised it. Okay, yeah, thanks, Matt.
The tuning.
I figured you knew that. Anyways, yes, there's definitely, and I think there's intention behind this, right? Like, what is that even?
Yeah.
Right. Yeah, this is like a whole class unto itself. We're actually gonna have a class on this in a few weeks by a musician. But yeah, there was actually, I'll just chime in quickly. There was a study that I had read about in the late 90s, carried out on a really big data set of mice that were subjected to like one control set that had no music and they had to make through a labyrinth. And there's a certain average time that it took them to get to get the cheese at the end. And then one set, several hundred of these mice were subjected to classical music, some Mozart, I don't know what else. The other set was subjected to death metal. And of course, the classical music set made marked improvements compared to the control as far as getting through the labyrinth and learning from their mistakes much more quickly. The death metal set started cannibalizing themselves.
Oh, God.
Wow. So there is that as far as like something to work with on a material level.
Just one data point. Yeah.
Yeah. I don't know, Richard, you throw your question out there too if you want, and then we can maybe move on.
Okay. Michael, you mentioned LNER experiments a few times.
Yeah.
I was just curious, do you actually have any interesting LNER stories to tell?
I think nothing coherent, nothing special to tell. No.
Okay.
Yeah, no.
I didn't want to go off track, but
yeah. Okay. So I just want to see if I can talk briefly. Matt, is there a time frame that we want to stay within?
We're pretty flexible, honestly. So let your muse just do her dance. And
Very good. Yeah. So this paper came across my desk, as they say. Somebody did a study of the magnetic field structure inside of it's inside the center of a galaxy. So this is one of these incredible creatures, galaxy, and you can see this particular one has something very, exciting going on in the center region of it. And so this whole study is just based upon observations of that center region, which you can see looks like you could imagine that being a donut. Those are stars. I'm sure there are many thousands and maybe millions of stars in this, but just the bigger ones are showing up on our telescopes here. But this is a ring of stars near the center of this particular galaxy, and the observations have to do with that. I should also say that this was triply exciting because it was based upon 3 different observations, one from the ground, the ALMA telescope up in the mountains of Chile there. So ground-based. It was also based on there's satellite telescope data as part of this. And then the SOFIA telescope, which has since been retired, but it was a telescope that was flown around inside of a modified 747. And it had very particularly strong abilities for measuring magnetic structures, magnetic fields, polarizations at very small distances. So those 3 go together. And this is the particular diagram where I went, wait a minute, what? So this is pictures of the magnetic field, the direction of the magnetic field in that center starburst donut. And what's notable about this is the 3 different telescopes are combining to give us 3 different directions of the magnetic field. There's not just one direction, and there seems to be a certain just like a certain simple pattern here that they're not going in all different directions, but they're also not going in the same direction. And so if we ask ourselves, what would you predict? So you have some theory for how galaxies work and how star-forming toruses might arise. And does your model, predict this? Does it predict you would see magnetic fields that have these slightly different orientations? What I'm going to show is that if you have an electric universe, or just an electric model of galaxy formation, then actually, yes, you would predict such a thing. What we're looking at here, the center drawing here, this is how current flows through plasma. So what we have is we have a current flowing from right to left, and we start off with it just flowing down the center. So we imagine that we have space filled with charged particles, and we're not going to say how yet, but we are going to say there's a current flowing, an electric current is flowing right down the center there. Okay, if you examine the laws of physics applied to the situation, and you ask how will the system evolve, what will happen once you start doing that, and what you find is that if the system wants to minimize energy, which is a phrase, a technique that is used a lot by physicists. We understand that nature doesn't waste energy. Nature doesn't, like, if I drop something, it doesn't first go up and then go down, right? I have to throw it up if I want it to go up. And so that's just a simple example of what someone means by minimizing the energy. The lowest energy outcome of dropping a ball is just that it just goes down, right? So you ask that in this situation, admittedly, it's a little more complicated. And what you'll see what will happen is that that initial current going down the middle will have to start rotating around itself. And that's this first arrow here. It starts rotating around. But then if you continue to pump the current through, right, this is all premised on the idea that you have the current continues to be pushed through. Then around that second layer, there will have to be another layer. But then this one, it's rotated so much that it starts circling around the center, right? It's not even flowing down the center anymore. It's circling around, and then that trend has to continue, and you will have to get the rings outside of that start to spiral back the other direction, back the way that the original one came. And then there will be a layer, a coaxial layer, which is flowing directly opposite, back up the way you came. And then that continues, the rotation continues. In this case, as we're looking at it, the arrows continue to rotate counterclockwise. And then that one that's flowing back outside of it, there'll be another layer that starts to twist. Outside that, another layer that then circles, but now going in the other direction. So this is a very beautiful, complicated structure that was initially described by Lundquist back in 1950. He didn't do any experiments with it, but he laid out the basics for how a physicist should think about this. And then Don Scott, back whatever it was, 8 years ago or 10 years ago, filled out. So Lundquist never made a picture like this. He only made like the first two layers there, maybe the first three. And then he just stopped his analysis. And then Don Scott took it and he kept going with it to show this. And so this is sometimes called a coaxial current flow, because you have these different things going on at different radii away from the center, like a coaxial wire current. And do we observe these anywhere? Well, what we do observe in a variety of cosmological settings is current flowing one way and then it flowing back the other way, and then flowing the reversals. We see the reversals, but up until I saw this particular paper, I've never seen any data that shows the transitions between the one direction and the other direction. So for example, Denise Gabuzda, she's a astronomer in Ireland, and she has a series of papers on coaxial current flow in active galactic nuclei. So there's some galaxies that are shooting off these giant jets of particles up and down off their axis. Complete mystery for the gravity people, but anyway, we see it. And so she was able to find enough galaxies that were oriented just right towards the Earth so that she could study, is the current coming towards us or is it going away from us? And she found in several cases this kind of nested structure where in the middle it'd be coming toward us, but then a little way out it'd be going away from us, right? So that much we have observational data on that. And so when I saw this, I was like, holy cow, I think we are looking at those different directions. So the picture, I don't know if I didn't really fill out the picture, did I? Not so much. Okay, go back to this. So you want to imagine that this ring here is that center of the galaxy. There's some current flowing. And as you move away from the center of that ring, the direction of the current is changing. So that when you look down at the ring, you see, I'm sorry, I'm kind of bouncing here. As you look down on the ring, you see that direction changing. The ones that are, say, the dark blue ones might be the ones that are closer to the center, whereas the orange ones might be a little further out from the center, and then the red ones, and then the orange ones would be farther out still. I can't prove that that's what's going on here. I would need to dive in much deeper to their data analysis. But I am saying that with an electrical model of what might be going on in that center starburst donut, if you have an electrical model, you would predict that you would see, depending upon how you're looking at it, you would see the currents oriented in different directions as you moved out. Whereas from a gravity model, if you have a gravity-only physics, it's like, no way. It's not even on your, it wasn't even on your whiteboard. It wasn't even a proposal. It never even occurred to you that you would see such a thing. But an electric model, you would predict it. But then, like I say, I haven't proved it. I haven't proved that these blue lines are the ones that are in closer, right? I haven't shown that. I haven't shown that the blue ones are this and the orange ones are that. So this is really just kind of a, I don't know. I don't want to summarize it. It is what it is. I said what I said. So that was the one diagram that really got me excited from this paper. The coaxial current model would actually predict that you would see magnetic fields going in different orientations as you move away from the center of the ring. And then if you look at the, there's an energetic way you can look at this. If you do have currents flowing through a plasma, you can look at the kinetic energy. You can look at the energy bound up in the magnetic field. You can look at the gravitational energy, etc.
Somebody needs to be muted. I'll just do that.
Okay, that's fine. I was rushing. That's fine. Okay. And if you do that, if you apply this to when they applied this question to their data about this galaxy, this is their sentence for how they explained it. The energy balance in the interstellar medium of the starburst ring shows that the magnetic energy is in close equipartition with the turbulent kinetic energy. Both energies are a factor of 10 higher than the thermal energy. These results imply that the starburst ring is magnetically critical where the clouds are supported against the gravitational collapse. Okay. I think there's a certain amount of misunderstanding of what's going on simply because of the models that they are forcing themselves to use. I think what they are saying, or I think what their data is saying, is that this structure, this center starburst region, is being held together by the magnetic fields that the current flow is creating, which is exactly what we said about these donuts of flowing electrical charge. They hold themselves together. The forces hold themselves together simply by the way that they're moving. And this paragraph here, I think, is really saying that. It's saying that if you look at the energetics, it's holding itself together because the flow of current is creating magnetic fields, which then keep the current flowing in the structure that it has. And that those two energies are much higher, 10 times higher than the thermal energy that's in the system. Thermal energy always, from the physicist mindset, the physicist modeling of the universe, there's always this thing called thermal energy. Everything has a temperature, and the best we can understand it is it has to do with random jiggling. Thermal is always some kind of a structureless energy or structureless motion, and it's always present everywhere. So what they're saying is that what's holding this thing together magnetically, the center starburst region, that holding together force is 10 times higher than the thermal force, which totally makes sense, because if you think about your body, for example, there's thermal energy in your body. What if the thermal energy in your blood was higher than the energy holding together your arteries? Well, then the blood would go flying out of your arteries, right? So the arteries have to be much stronger than the thermal energy in your blood to hold everything together. And I think that's what's being said here. Okay, so now I'm going to wrap it back to where we started, and get us back to the idea of a fractal toroid. So I want us to think of a galaxy as, I started with this. This is a great set of data from Kalak. Yes, Kalak. He put out some great papers. He built a self-sustained plasmoid fusion device and then was never heard from again. So I'm like, wow, they can't kill all of us, can they? Why is that big? Go smaller. Whoops. There we go. Here's that center starburst ring. That's that coil of current that in which all those stars were living. And when you do that, when you set that up, there's a larger structure to the torus that comes about when you do that, which is kind of between these two diagrams, you can kind of get a feeling for it. What is the structure of a torus when you do that, when you send current in a ring? Now you can put a person here too. You can put a person right there, and that would be the heart, and that would be the structure of your magnetic torus around your body. So it seems to be a universal. Every living creature seems to have this pattern to it. Okay, so if you take that as the structure of the galaxy, the first structure of the galaxy, then you can do this kind of a breakup. This is a particular drawings from Nevesky, a Russian, some good Russian papers on this. As often, the Russians are farther ahead of us on a lot of these things. So if you take in this case, the black is our original current. It's our big torus that we're trying to set up. And then the blue are the fields, the toroidal field around it. But once you start doing that, as I found by looking at my simple analysis, when you get close to the edges of the current itself, when you get close to the current itself, the forces kind of get out of control. And whether that means the thing blows itself apart, maybe, or it could mean that it transitions, a phase change, if you will, a phase change to another structure, which might have the same energy as the previous structure. But now you can see that the black lines are still the current flow. And now the current flow is going perpendicular to what it was to start with. We still have the same overall body, but now we've created, or it's self-created, a structure that looks like itself inside of itself. And that can happen again. And so this is the third phase of that. You can see that each of those previous black rings has broken up into a smaller set of black rings, which are now circling around perpendicular to the one they came from. And what's cool about this analysis, according to Nevesky, is once you reach the third level, okay, so level 1, level 2, level 3, once you reach the third level of fractal structure, something really amazing happens with all the electromagnetic fields. I don't understand it. I haven't studied it that much, but I think he's right. If I just have a current flow like this going to my initial structure, it's going to radiate all kinds of energy. Fine, that's great. This one too, it's going to radiate all kind of energy. Cool, like ball lightning. It's going to radiate a bunch of energy. Once you get to this though, the energy no longer radiates outside of the structure, which is astounding. All that electromagnetic energy, if you look at the way that if you go through the right-hand rules and you're finding the pointing vectors and you're taking E cross B and you're like, where do all the pointing vectors point? You find when you reach that third level that all the pointing vectors, all the energy emission from the electromagnetic fields stays always inside of the structure. And that kind of opened up for me, like, you know, if galaxies are electromagnetic structures, why don't they just blow apart? Great question, right? And there's various ways to answer that. But I had never thought before that one of the reasons they don't blow apart is because when you get enough structure within structure within structure, then the energy stays within the structure. And I just loved coming across that as somebody else's, research into toroidal moments. With that in mind, then, this is amazing, right? That's the center of our galaxy. Woo! That is just outrageous, right? Most of what you're seeing here is energy emitted from synchrotron radiation, which is the spiral movement of electrons. And so like this right here, this giant line going up there, you have to imagine there's several 100 billion amps of current flowing up here, just flowing straight up. And then all that flow causing electrons to spiral is what emits the radiation that we pick up way over on the outskirts of the galaxy when we look in. And the reason I put this on the essay is because even just glancing at the center of the galaxy, you can see that there's circular structures that are at right angles to other structures that are at right angles to other structures. And I'm not claiming to have analyzed this like completely to tell you what's what, but I'm just saying from a perceptual point of view to be like, well, what would you expect? What would you expect if the heart of the galaxy was this incredibly complicated electromagnetic current system? And I'm saying from pictures like this, I'm saying, well, one thing we could predict, if our models are right, we could predict that you would see structure within structure within structure, and that you're going to see a lot of this kind of perpendicularity, that a larger structure is perpendicular to a smaller structure. And that's what I start to see when I look at images like this, from the center of our galaxy. Okay, I actually think there's another picture of it. Whee! I actually think that was where I wanted to get. We just got through everything I thought to say.
Right on. No, that's quite the voyage. Couldn't have gotten any bigger. Maybe, yeah, no, that was quite something. All right, there's a little line of people who have been waiting to pose a question. I'm gonna just throw a quick, maybe elementary, basic question that, for galaxies, like we're in the Milky Way. I've not quite wrapped my mind around how it is that we have adduced the structure of the Milky Way galaxy, and there's like 4, maybe 5 arms to our galaxy that have been calculated. Yeah. How did they come up to that conclusion? Because certainly we didn't shoot out satellites to take a photograph of it. So we see other galaxies and safer galaxies that have that characteristic. So how do we know about our galaxy?
Yeah, great question. I would say it's a pretty even mix of evidence and conjecture. So evidence being, like you said, we can look at other galaxies that we think are similar to ours. And so we can say, okay, there should be this kind of structure. And then we can look around and we can find, a blob of dust over there. And then we can't see anything for about 45 degrees. And then we see another blob of dust over there. And those two blobs of dust are in line with each other and, could be part of an arm. And I really do wish, if only astronomers would be humble enough just to say that, instead of saying, here's a picture of our galaxy and here's where we are. And we know that, the structure, the details of the structure of our galaxy, according to the textbooks, has changed, I don't know, 2 or 3 times, in the last 60 years. And every time it changes, then we think we know, now we finally got it.
Thank you. Yeah. I appreciate that immensely. It's not just me. Okay, it's not. There's ambiguity. You, right? Okay, all right.
Yes. Cool. I've reached the point where it's not quite as bad, but it's almost as bad when I listen to scientists speak. It's like listening to politicians speak, and you just have to have that other side of your brain that just goes, They're lying, they're lying, they're lying. And then you just later you put together what you think you heard, right?
Right. Yeah. Well said. All right, Jerry.
Okay, thanks, Matt. Thanks, Dr. Clarage. I do love reading your Substack, Doctor. It's fascinating stuff. And regarding both the in the first part, the toroids around toroidal shape you had, but also the electron one you were trying to generate.
Yeah.
Now, I'm just throwing this out. It's a wild idea, but what it reminds me of is, astronomy, in that, say if you were trying to launch a satellite into orbit and you blast off from the planet, initially you have this, I call it a centripetal tendency, to spiral back down to the Earth. But if you keep going farther enough, if you go too far, you developed a centrifugal tendency to spin off.
Yeah.
But in between these two tendencies is, I don't know if you want to call it a layer or an edge. They call it a sweet spot where you can actually have geosynchronous orbit, and you can put a satellite there, and it requires very little effort to maintain it in that orbit. And to me, what we're trying to do with toroidal generation with electrons, plasma research in that, is we're trying to find that sweet spot of geosynchronous orbit of the electron. Now, that's just a wild idea I have, but anyway, I wanted your comment on that, if you have any.
Yeah, I like it. Let me see if I have anything that would be. It's very much what I was wrestling with, and just for the sake of something to point at, I will go with. Oh well, I didn't put them all together, did I? What you say is certainly applicable to this. There's the added complexity that the electric force has repulsion as well as attraction, but it might be analogous to like the thruster. Like you were saying, if I keep applying a thruster to my rocket, that will tend to make it go away, right? So if we, that's what I was wrestling with here, is how do you combine that inward tendency, which is represented by terms like this, that's the inward tendency. How do you balance that with the outward tendencies, which are things like this and that? And basically, you just said, well, so I looked at those. What's the outward tendency, as you're saying? What's the inward? And can you balance them? Can you put an equal sign? Can you put an equal sign between them? Which is exactly what you do in the satellite case that you're talking about, right? It's just a little simpler because you only have velocity and distance away. I think those are the only two parameters. But I think it's a similar question to what you're laying out.
And I tried to develop this idea of a centripetal tendency and centrifugal tendencies, so you don't have to use the nonsense about gravity, and you can stick to just electromagnetic energy to it. Anyway, I made up that thing about the tendencies, but I like it, so you don't have to say gravity.
Oh. So I'm not sure I'm following then. So you said you were looking at the satellite case, but then you removed the idea of gravity?
Well, I don't believe that gravity is a force the way Newtonian physics describes it. It's a phenomenon. You see it. So there is a centripetal tendency, and I don't call it gravity, but there is this centripetal tendency. And then there is a centrifugal tendency, and I don't call that, anti-gravity or whatever you want to call it. But it's you find this sweet spot, which I think, it's we're trying to get at with the work with the electrons
Yeah.
in different extremes.
Yeah. Yeah. The part of my intuition why it might be different in the case of these exotic vacuum objects, that go smashing into is because they seem to be held together so tightly. Is part of why I think it's not really a balancing act. They have locked somehow into a structure that is immensely stable. It's not some boundary. It's like it's yeah. But I haven't proven any of that, but that's just from my looking at it, why I think it might be different than, kind of repeating myself, different than the case of some boundary condition where you can make everything just balance just right.
Okay, thank you very much.
Yeah, you're welcome.
Brett Walters, are you still there, Brett?
Yes, I am. Thank you for the presentation, Michael. I just wanted to ask, you've often in other lectures portrayed the Earth as basically as a functional organism in the solar system, and then the solar system as kind of a functional organism in the galaxy, and the galaxy is probably also a functional organism for something higher that we cannot really observe too well.
Yeah.
Just wondering, do you think that with that in mind, is there something to astrology in that maybe planetary motions or positions influence humans on an emotional level, or do you think that's mostly just bunk, or is there something else that people are missing?
I think it's very much there, that influence, very much there. On the one hand, it was a science that I think we've lost some of the understanding of the basic principles of. So we're kind of in that disadvantage of we've gotten fragments, we've inherited fragments, and then we try to, assess, well, is this a real science or not? Now, having said that, it almost seems laughable that a scientist would say, hey, do you think it's possible that we're influenced by the world we live in? Kind of like, wow, I don't know. Do you think that? Wow, yeah, let's think about that. I know beyond a doubt that planetary influences affect the mass of humanity. But it's kind of a statistical thing where you can't necessarily predict where one particle is going to be, but you can without a fraction of doubt, you can predict, what will happen to the mass of particles. Like if you're approaching 32 degrees Fahrenheit with water, it's going to freeze. You don't know which ones are going to freeze first. You can't, but it's going to freeze. And so planetary influences, I see the same way. When certain things happen out there, so to speak, stuff's going to play out in the human realm. It's just going to. Does that mean that you can predict which people will do what? No. But if you have the right understanding, it'll be child's play to say, yeah, the mass of humanity is going to do this now. And I think that's, from what I can tell, that was certainly one branch of astrology, was understanding what happened to the mass of humanity. And it wasn't only humanity, it could be the mass of animals or plants, whatever. It had that level to it. But then in terms of, does it affect an individual person, what I've come to so far is that it can, if you are a certain kind of person. For most of us, no, it doesn't. It literally does not apply to us individually. It's no more than the law of freezing applies to any one molecule of water. But occasionally, you find a person, a figure in history, which is actually, yeah, I don't know, connected to or affected by or is expressing these planetary influences. And I'm sure there's many we've never heard about, but are there any that we have heard about? And I would say that some of the people that, you know, have changed the direction of, or at least appeared to change the direction of history, you know, like a Napoleon, I think he was connected at that level. I've read a few of his, not letters, maybe journal entries. I forget where they came from, but you know, he knew how things were going to play out. He knew which battles he would win. He knew which ones they would lose. He knew if you went over here that this would happen. So he was just connected to a different level. And now, did that make him a happier person? I don't know, you know, not necessarily. So I'm not saying we should all want to be. I'm not saying we should all want to have individual, to be recognized. We should not all want to be recognized by the planetary gods. But I'm just saying that it's occasionally, it seems to me, it's occasionally possible to see it play out on an individual level.
Yeah, but according to that was awesome. Because according to our dogmatic science paradigm, the planets, it's just random chance where they are. But when you look at like say the position of the moon as an odd example, it's right at the perfect spot where you have where it covers the sun perfectly during a solar eclipse.
Yeah.
And you have to wonder, okay, maybe things aren't where they are by accident if there's too much synchronicity going on like that. And thanks for your time.
You're welcome.
Cool. Sherry.
Thanks, Matt. Thanks, Dr. Clarage. I really like your nature doesn't waste energy comment. And when you were going through that discussion, the question that came up for me was, what is the ignition of the movement? Because is it something that ignites once it's like, what causes that? Well, because I relate to the body again in my quantum healing, and that is we have two phases of what we call inhalation and exhalation in our body. And I believe that so does all of the cells in the universe, where, you know, the polarity can flip, or we can go from what you refer to as centripetal to electrostatic. You know, it's like we all have this inhalation and exhalation expression, what we call it, and whether it's a electromagnetic influence or whether it's some other kind of form of ignition.
I was thinking of a similar question too. I think it's been sort of hovering over Dr. Claridge's presentation in some ways as a variable, but yeah, what is it that drives this? We've got this oscillation process that's causing these toruses to be generated, to create these structures and to create this sort of shape in which other subtoruses emerge all over the place. But yeah, what would be kickstarting that process? That's a great question. Is that answerable?
Good boy. Well, so pieces of the answer. One piece is that in the case of Ken Shoulders, who created them at will in the laboratory, we see that intelligence is required. You have to arrange a bunch of electrical equipment in a very particular way, and you have to get good at it, and you have to practice it, and you have to want it, and then you can create these things, right? So that they don't just fall off the shelf, you know, so to speak. So intelligence and desire seems to be there. And then, but I was also hearing in your question, you know, something along the lines of like conception, like how does, you know, if a person is a torus which has all these sub-Toruses. How did that start? Well, we all know there was a conception that started, if you want to, you know, roll the clock back. And then we're into this whole other world of, well, you know, we have to change all of our discussion. And I think the same will be true of stars and galaxies. That's how I see it now, is that every star has a mother and a father, but that's not what our astronomy has ignored that so thoroughly that it seems like an absurd statement now, you know, to an academically trained astronomer. But the more I learn about it, it's like, oh no, it's got it. We just don't know how to describe it yet. But every star has a mother and father. Whatever that means at the solar system level, I don't know. But that's how we got to start asking the question.
Well, there's two books on this matter that might help with these questions, and one is by Dr. Thomas Cowan, and he's anthroposophical, a Steiner follower, but he wrote a book called The Cosmic Heart. And then there's another doctor, Randolph Stone, who wrote about polarity of the body, and basically we train in this field of understanding that our body is made of the particles of the galaxy. And so why would the polarity of the galaxy be any different than the polarity in our body?
Yeah.
And then we then we begin to wonder, so yeah, when you talk about the cosmic and you know, how we ignite into being inside a woman's womb.
Yeah, there's a lot of forces involved with that.
Yeah. But it's more than magic. Anyways, I could go on with you. I love I love pushing this quantum side in you because you can go there. This is wonderful. I'll leave my questions to that.
All right.
What are your thoughts of Halton Arp?
I think I need to know more about him, but I'm not going to do the research myself. Everything I have heard about him, he just seems awesome. He just seems like, you know, there have to be Halton Arp. What were those things? The mathematicians used to publish, you know, the 10 most important questions in math, and then everyone would go trying to answer those questions. Somebody needs to publish the 10 most important Halton Arp threads that need to be followed up on. But I don't know what those are. I haven't studied them that much. But he seems great.
Cool. And I like that. I like that proposition. I'm all right. Let that be amplified into the zeitgeist. Let it
All
be
right.
done. Right. Kevin.
Thank you. Amazing. I just have some pretty open-ended questions, and it's great after that quantum discussion, and even the comment about a zeitgeist. But what are your thoughts on unified field theory? And then another one would be, what are your thoughts on holographic reality with all your research?
I think the whole unified field thing is the height of misguided hubris.
Okay, nice.
That's a short answer. I mean, it
Which
really
part of
is.
it, I guess.
You look at the history of that sort of thought. I'm gonna write down a unified field equation that will explain the universe. And it has to keep changing as our models keep changing. Every 75 years or whatever, there has to be a different formulation because we've learned something. And so I'm a little. On the one hand, it's fine because it's great that humans love to think about these things, and at least they're not building bombs, and it's all, it's great, it's good. On the other hand, there seems to be this, it seems to be a magnet for this kind of worst kind of intellectual arrogance. Get away from me, you lowly people who don't understand my field, unified field theory. Anyway, I see that play out that way. But it's just guaranteed that there's terms we're not including. I mean, eventually, maybe, you know, we'll have the love term. Someone will discover how you can actually measure love, you know, and then it'll be like, oh, that explains all kinds of things. Why, you know, why my field theory didn't work out or something. Yeah, I'm not too hot on the unified field theory research.
Well, thank you for your unfiltered opinion. That's why I asked it. And what about the holographic reality?
Poof. Yeah, well, don't you think? I mean, I think. It seems to me that. Well, okay. I was giving a lecture not too long ago about how the eye works, and this kind of mysterious fact that the image of the world is there inside my eye, right? And then all kinds of electrical stuff happens. But I believe that the world's out there. And so how does that happen? I mean, if you ponder on that, you get a little loopy, like there's some trick going on that I actually believe what I'm seeing is out there. And I think that might be one way to look at the holographic universe. Like anything that you can imagine or think or see or talk about is inside of you, but it's also outside of us, maybe. You know, so it seems, I don't know if that's what you mean by a holographic universe,
Yes.
but that's what occurs to me.
Yes, exactly. Especially with the fractals and when we're looking at all these different levels of fractals.
Yeah.
Thank you.
Yeah.
Blowing off of the unified field theory stuff, what would be your assessment overall? Like, it seems like the camp is very polarized around Einstein in terms of those who think he's the greatest thing, like the greatest genius in world history, and others who think that he's a total fraud, liar, cheat, whatever, like the worst things you could throw at him. I'd imagine that you don't fall into either camp, but what's
Right.
your general assessment of Einstein?
Whew. Well, everything I've found out about him by intentionally looking, I am very touched by his humanity. He seems to be someone who really felt about things, that was really touched by things, who never seemed to cross into that intellectual arrogance. I'm sure he had all kinds of problems. I'm not trying to glorify the man, but I'm just saying that he seems to be as advanced scientists go, he seemed to be a decent guy. But in terms of his science and is it the best and whatnot, again, it's like, okay, his general relativity, the field equations, they're a consistent expression of a metric, and you can throw mass and energy into that metric, and it'll show you the tensors will show you how to find the curvature and how to define distance. It's beautiful. It's beautiful, right? Does it explain anything about the universe we live in? I don't know. I'm not so sure, frankly. I don't know. You know, I could go back to that. Remember, I was talking about the electrons curving in a magnetic field. You know, we have a law that expresses it, but you know, does the universe think that way? Is that really how the universe sees it? No, it's just I don't know. I'm pretty mixed on the whole thing. I don't have a great appetite for developing some mathematical theory that only works if we live in a gravity isotropic universe. We don't live in a gravity only isotropic universe. Duh. So I'm not gonna throw my weight behind whether or not, you know, I want to defend his general relativity or not. I'm just not going to do that.
Cool. Sure. Thank you.
Yeah.
Sue.
Thanks, Matt, and thank you, Dr. Clarage. You had briefly mentioned that the arterial energy would need to be much stronger than the thermal energy, or the arteries would blow apart.
Yeah.
This made me think about a previous lecture where you talked about the hierarchy of life itself. So cells communicate on a cellular level. I think you said, and the organs would communicate on another level, and then humans and the solar system. And I was just wondering if this further articulation of the toroidal donut and the fractal nature of energy would shed further light on how that energetics may be allowing for that kind of communication to happen on each of those levels.
Yeah, I definitely think so. And I'm just thinking back over the last hour and a half. I think I was trying to touch on that, and if we just look at so on the one hand, there's the raw kind of simple, let's circulate a bunch of electrons, and let's see what happens. Can we make a torus within a torus? Does this seem to somehow fall out of the laws that govern matter? And then looking at, I think, like what I think I might have drawn this last time we all talked, that that structure of the sun having this giant toroidal. Let's see, is that visible? Not really. Can you see that at all? I don't want to draw it. It's not going to be visible.
Yeah, it's good.
Okay, so this universal pattern of circulating energy, which forms an overall toroidal structure, that is absolutely mirrored, at the planetary level. Every planet, I mean, to more or less degree, has a similar kind of, and then the moons, especially of Saturn and Jupiter, the moons have the same exact structure. So that, not only do we see that in the cosmos we live in, but from what I was talking about today, it's totally in line with how we know just the fundamental forces of matter work out. So, and then you're saying, like, in terms of the communication, then we have to, this is just a cartoon, right? And if you just take a little bit more time, then you find that there's literally they're called flux tubes by the astronomers. There's these tubes of magnetic and electric force that reach out from the sun to every planet directly, like direct connection. It's not a connection at a distance kind of thing. It's like direct. But then also every planet has them with each other. So if there's a lightning storm on Jupiter, you can measure it in the Earth's ionosphere, right? There'll be a little bit of a ring if there's a lightning storm on Jupiter. This is the plumbing, this is the wiring, this is the mechanics, this is how matter plays out. But then what for? Why? Right? Because, well, from a simple level, because they all have to talk to each other. If they weren't able to talk to each other, then the solar system couldn't be a coherent something. Just like your heart has to talk to your head, and your head has to talk to your arm, and your arm has to talk to your liver, etc. But boy, it really makes, so we were talking before about the astrology question. And could it be that this giant structure we live in actually affects us here on the planet, right? And kind of, I think, seems like everybody on the call thinks like, well, yeah, of course. And what I'm more and more interested in as I get older is any communication is two-way. Every antenna is also a broadcaster, and a receiver. Every antenna is a receiver. Every receiver is an antenna. The communication is designed to go both ways. So what are we doing, or what am I doing, that can broadcast back up? And well, I should rephrase that. Everything I am doing is broadcasting back up the chain also. And every thought I have and every interaction I have with someone, as small as it might be, is part of what is being broadcast back up to the planet, and then consequently back up to the sun.
Yeah, it's a beautiful, empowering concept, eh? Because I mean, you have it both on the physical level, as you say, it's hard to even, as you kind of alluded to, it's hard to say where our field of influence ends. You know, you're like, even the sun, you're like, it's probably a light year, maybe more, right? Maybe it extends even beyond that in a certain way. Same thing for everything physical that has these fields, but at the same time, then the question of intention and ideas and thoughts also add to this as well, because it's like, how does that additionally influence how many people get to experience the joy and the pleasure of chewing on these types of ideas that expand their minds and their sense of reasoning powers to the type of scope that you've brought us to. Right? Most people live years and entire lifetimes without getting a chance, maybe because the political agencies influencing our culture and our schools, perhaps, maybe, but they don't get a chance to really expand those conceptions that far beyond their immediate sensual experiences. So it's really, how does that then play into these higher, more subtle forces as well that tie us to the entirety of the universe? Like it's dizzying.
It is, and if you a little bit of historical investigation will show that a lot of cultures, when there was a cataclysm, will sometimes link the cataclysm to the fallen state of mankind, humankind. And I'm just thinking one is just coming to my mind directly: the Central American cosmology. We're in the fourth or fifth version of humanity. Like there were four previous versions of humanity, and one of them, the second one or something, or the third one, I forget which, had to be wiped out. There had to be a cataclysm, wipe them out. You know why? Because they weren't sufficiently grateful for having been created. And, that's a wonderful metaphor, story, analogy, but I think it's right in line with what we were just saying. Like, could it be that all humans together would have fallen to such a level that we no longer fit with whatever, the Earth or the solar system, and that the solar system, as a living, intelligent creature, might sometimes have to do something to rid itself of something that's gone off, something that's gone wrong. And I'm not saying I necessarily believe what I'm saying. It's just we tend to make fun of such statements. Oh, those silly people, they thought that what they did affected the earth, those silly people. And no, they're not silly people. They're not silly people, and maybe there's some truth to it.
Amen. Do you have time for I see three hands. I feel like I don't want to keep you too long, but do you want to do three more questions?
Sure. We'll do the three and then call it a night. Yeah.
All right, cool. Kelly.
Yeah, I have a question. You've probably been asked this before, but I'm kind of obsessed with this topic. What do you think about the ether?
The ether. I don't know what the ether is anymore. My brother gave me this beautiful 1-inch thick book it was someone put together, a collection of the most relevant ether studies papers as of like 1890 or something like that. And I looked a little bit at it, and there was nothing wrong with ether theory. I couldn't quite understand most of it, but it wasn't like it needed to be discarded or thrown away. But coming back to my initial statement, I don't really know what the ether is. So I mean, I understand the argument that if you want to have a wave traveling through something, then there has to be a medium that the wave is traveling through. And I'm like, well, maybe, but I don't know. Maybe not. I just don't understand I don't understand it well enough is all it really means.
Monty.
Yes, thank you very much. Yes, Michael, I was noticing a rather colorful display behind your walls of the five-sided petals and the pentagrams. It reminds me of Kepler, who came up with the idea of the harmonic ordering of the universe. And if I remember correctly, he attributed much of his inspiration to this to the Platonic solids and the nesting of the Platonic solids to come up with this theory. I'm just wondering if you see congruity in this insofar as this type of ordering principle, and if you were inspired by that also.
Yeah, that was one of the things where I fell in love with Kepler reading that book long ago. But are you asking like inspiring just general, or in terms of the ideas we were talking about this afternoon?
Well, I'm just wondering if, as far as the fractals, in other words, it seems like there's a nesting so far as from the larger to the macro to the micro, and so far as this ordering principle and a harmony within that. I was just wondering if some of that shapes your thinking insofar as your pursuit of these ideas.
Yeah, well, it's interesting you're bringing up the connection with the solids. A good friend of mine, we sometimes collaborate, and he's much more geometrically thinking than I am, and he will often, throw out these geometric statements, and I'm just like, oh, I don't know if I understand, and he's like, no, it has to be that way. So my point being that the whole this jumping in to the Platonic solids or other, the jumping into it. I could easily imagine in my future needing to look at all of that much more carefully. But the last time I read the Timaeus, I think I absorbed about 0.01% of it. So
there's a fun section in Kepler's Harmonies of the Worlds where he goes through space packing in the two-dimensional space and then three-dimensional space. Wow. And it's fun because in book 2 on the two-dimensional space and just looking at how do you fully like pack space and where are the cracks, especially when you get into pentagons. He introduces what I think is the earliest example of Mandelbrot systems that are just always going to have an ordered asymmetry, because they'll always, as soon as you introduce like pentagons, which involve the golden section, into your tiling, all of a sudden it's always going to be an open system. And you'll start getting this change, but a harmonious changing quality that he challenges future mathematicians to work on, because he doesn't have time. That's not the purpose of him doing that.
Yeah. Well, that's like one of those. That's one of those cruxes right there, right? That as soon as you introduce the geometry of growth, then nothing is static anymore, and you have to look at. You got to look at. Yeah. That's very cool.
Yeah, it's fun.
Was there a third? Was that the last?
Yeah, there's last guys coming up here. Scott, go for it.
Hey, can you hear me all right?
Yep.
Yes.
Okay. Just on the question of consciousness of the universe, which is a probing question for me, and just what does that look like or really mean? And there's a guy I've come across called Federico Fagin on YouTube making the rounds. And I'm just wondering, he talks about quantum fields being conscious, kind of transforming our kind of, playing with quantum theory, I suppose. Quantum fields are quantum bits. And I guess the other thing is, we're going into supercomputing, quantum computing, which is a whole new realm. So I'm just wondering if you've heard of him, number one. And he's one of the guys who developed the, developed the 8088 Intel chip. He's got the creds,
he's got a little bit of cred.
yeah, just a little bit. And so he talks about, consciousness as primary and the quantum field. So I delved into it a little bit. Just wondering if you have, and it might be something that might add value to our query of the conscious universe.
Yeah. Yeah. Well, I'm still like the ether question. I think we don't know what consciousness is. I think our usual state of consciousness is just that, one state of consciousness, and for some reason we all believe that it's the reality. But in terms of like a quantum field being consciousness, it's seeming to me that any statement like that is flawed in the sense of that the consciousness has to be consciousness of awareness of something, and so there's different mechanisms to be aware of something, but the mechanisms to be aware of something are not the same as the awareness. So I mean, back in the day, right, it was somebody, I'm sure, proposed that brain cells are conscious, because that's, and then somebody else dug a little deeper and said, oh no, I'm sure it's the mitochondria, and then someone dug a little deeper and said, no, I'm sure it's the quantum field. And I think it's always the wrongly phrased. It's always wrongly phrased. A quantum field can't be conscious. Something could be conscious of a quantum field, but I don't know. These are such difficult topics, right? These are incredibly, and it's one of the only topics I continue to care more about. I'm not trying to dismiss it, but it's they're so difficult. They're so difficult to talk about.
Yep. But it's a process, right? And I think at the end of the day, like, you got our engines revved and hypothesizing, because I guess the part of it is just there is an ambiguity in a lot of these questions, which is important to kind of not feel like we have to get a crystallized full formulaic answer.
Yep.
But whatever it is, definitely it's been amplified in the course of this excellent presentation.
Cool.
And I mean, I really always appreciate these things so much, Michael. And you have like this wonderful just humility and ability to just say what we don't know, and to just admit, like, it's so rare to find in the scientific world people who could just simply say what is not yet known. And it's a breath of fresh air, because you're like, okay, there's space to move, right?
Right. Anytime you pick up a science textbook and you see a sentence like, we now know that, you can basically just cross off that, right? It's just like, anyway, thank you. I appreciate it. Yes.
Cool. All right, sweet. So look, thank you, everybody. Michael's Substack is fantastic. It's going to be in the description box under this video on YouTube and wherever else we post it. So definitely subscribe to that. And next week, we're going to have a presentation by, I believe, Anton Chaikin, dealing with some of the implications of his new research and new book on American history and the Who We Are, America's Battle for Universal Progress, Volume 2. So check that out next week, 2 p.m. Michael, thank you so much for sharing with us today, and I look forward to future chats.
Yes, thank you so much, everybody.
Thank you.